Hi, good morning everyone. I'm from UCI, Institute of Transportation Studies, and today I'm going to show how we, from the zero, collecting the data to analyze the vehicle lane changing maneuvers through the area photos, and how we accelerate and clean the data, and how we visualize it, and looking at how the pattern, how the lane changing pattern is on the freeways. Then everyone knows that the lane changing maneuvers will reduce the freeway capacities and is more unsafe, and will decrease the bottleneck to discharge. So it downgrade the freeway performance. So we're interested in looking at the different freeway designs' impacts on affecting the lane changing maneuvers. So we also want to see, like, is it the traffic breakdown really caused by the increasing of the lane changing maneuvers? So here we collect the data. It was originally used to study the HOV facility, continuous versus limited access, and then we do the area photos in the 4 bottlenecks area in the Orange County, that which has different type of HOV facilities. Then we can see that the freeway geometry and designs are very complicated over here. So the traditional way of the computational way to automatically detect the vehicles in such small size is infeasible. So we did something more to extract the vehicle trajectories and to understanding the lane changing maneuvers. So this is one of the studies that we have on this XR55 around the I-5 area. We're looking at the northbound, and you can see here the main interest here is the weaving after this freeway-to-freeway connector from I-5, then which cause lots of lane changing behaviors over here. Then here is the simple schematic presentations of the study site. So it's about 1 mile, 5,600 feet, and there's a 2-lane freeway-to-freeway connector merging with another 3 lanes, main lane and 1 continuous access HOV lanes. So how we process the data is we hire 6 students working full-time in the summer to track more than 12,000 vehicles for about 80 to 90 minutes data. And so we use the company called Skycom. They take the photos and process it, and then the student track it through the Sky Trackers. Then we capturing the different kind of vehicles class, like a bus, truck, trailers, and motorcycles, and of course vehicles, cars too. And each vehicle's origin and the destinations information. And in every second we derive the speed and the location and the length. So the purpose of building this web application is we want to have a faster way to clean the data, and because there's millions of rows in the tables, it's difficult to look at one by one. Then we also have several colleagues collaborate with each others. We need to have a easier way to share the result with them, and then there are multiple study sites and many kinds of combination photos and the plots. So we decided to build visualization tools. So during my daily work routines, that mostly is every day doing coding and visualizing the data, and then distribute it to my colleagues and try to show that, ask them to revise it, and it takes forever to finish these loops. Then the traditional way of either using the paper reports or slides is not reproducible and it's not interactive. And so I decided just to build web applications. But building web applications is so difficult for like a non-CS person. And so there's lots of technology, like the previous presenter said, like Django, those things, using Python or JavaScript or something. And for our purpose is research the traffic data. So that's why I choose using R, which is a pretty popular language in the statistical and the machine learning environment. And it's open source, and it's also very popular. And there are more than 5,000 free packages available. From those 5,000 packages, I found Shiny, which was released in the end of the last year, that help you to make web application in 10 minutes. So they also released a Shiny server, which is also free, that you can host your server on your personal website, personal servers instead of their servers, to show your result. And this is the biggest advantage of Shiny is it adapts to the mobile devices. It doesn't use any flash, so it's pretty nice. So here's the beginning of how we clean the data. So you can see that before imputing the data, you can see this time over speed. Sometimes due to the airplane turbulence or some shadows of the overlay bridges and all those kind of factors will make the speed have some outliers. So of course there's lots of plots that you need to loop over to see it. So is there any better way or easier way? Of course, in the beginning we thought we can use if-else just to filter out those outliers, but it doesn't make sense because every vehicle's acceleration profile is different, and different study sites have different traffic conditions. So it's difficult to just set up a general if-else way to solve it. However, there's some crazy numbers like negatives or more than 90 miles per hour. I can first use if-else, and then I build a linear model for the accelerations over time. We can assume it's linear because it's pretty small actually. So identify the outliers by the statistical way to automatically clean the data and replace the data with the surrounding values. Then this is how we code the interface of our web application. So we code the VIS lab. It's a Latvian code, the best thing. And it's just basically the abbreviations of visualizing the lane changing behavior. And then we can, from here this website you can go to see the study site description and how the different among the study sites, and then we visualize the flow and the lane changing analysis among different study sites. So first we visualize the flow. This is study site 3, the same like with the photo we saw in the previous slides. So most of the traffics are through traffics. The upper rows was the origin and the lower rows was the destination. So most of the traffic in this study site was through traffic. But the second most interesting one was the freeway-to-freeway connectors to the main line. So we're interested in how these numbers will impact the freeway's performance. Then let's go back to the study site 3. First, we use we can select the origin and the destinations over here, and then we can set up the granularity, the time resolution, and space resolutions of the plots or visualizations. And then here is the first histogram where the traffic was generally not congested. So most of the vehicle we see, it's the through vehicle will do the right turn lane changing maneuvers after the freeway-to-freeway connector, and some will switch to the left, ahead of the freeway-to-freeway connectors. So here is the middle. The timestamp is middle. So here the conversion start to build up. So more vehicles switch to the left before the ahead of the freeway-to-freeway connectors. And so we're interested to see how to easily to visualize these patterns in just one plot instead of 1,000 words. So we use a time space heat maps with the dot represents the location, exact location where they did the lane changing. And you can see that when we merge both of the right turn and lane changing behaviors, most of the lane changing happens over here. So there are probably many kind of reasons, because there is another freeway-to-freeway connected to SR22, which is 1 mile ahead, and from here there's lots of overflies, bridge, and lots of weaving, and the geometry here is more scary for the driver, and here is like very open area, so it feels much more easier to do lane changing. Then we look at the vehicle who just dedicatedly do the right turn movement. You can see after the 6 minutes or 8 minutes, there are lots of lane changing happens over here. So we guess that it will cause the freeway breakdown. And here, before the congestion starts, vehicles tend to move to the left to avoid the downstream traffic earlier because definitely the HOV lane is open. So here is the speed. So you can clearly see that before the traffic starts to break down, there are lots of lane changing which match the previous plots, and then you generate the shock wave going back to the upstream. So our assumption is pretty valid for guessing how the lane changing behaviors will affect the freeway performances. So the key point here is just using R is very simple. You don't need to hire a computer science person to make your web applications. And the reason why I use this way to visualize data is I found a book called The Grammar of Graphics. It's written by a professor in Harvard that they shows why and how and to visualize the data. And this package called ggplot was made by Professor Haley Wickham in Rice University. It was his PhD thesis. It's really good to visualize the data in a static way and reusable way. And so R is a kind of it's a statistical programming language, but it can connect to database, handle big data, no matter what you like, and you can do parallel programming, anything, and you can visualize it now easily through the web. So our web application in this lab, it's effectively to provide the traffic flow conditions on the freeways, among the different freeways, and to see how the lane changing behaviors affect the traffic breakdowns. So during my studies in the UCI, the most annoying thing is every time I do my daily work loops, they always have questions in the midnight saying, Ming, just change this parameter, Ming, change this plot, Ming, change this, and I don't have to sleep. So this web application saved my life because I've, through most of my work products, easily just using few lines of code and the interactive can share with my colleagues so they don't have to call me in the midnight so I can sleep better. So this is the biggest thing that I learned. I found it useful for this building a web application easily. So thank you.